My goal is for people that do build management packs to try to show at least everybody in here one thing that either they didn't know about or they didn't know about as well. So I'll be interested to see if we accomplish that or not. But like I said, please fill out your session evals. Please leave comments. I love to read comments. And I love to take that feedback. I actually have a big spreadsheet because I'm a big geek. And I track all my session evals from all my past sessions and all the different code camps and other places that I speak. So, please take the time. That stuff really is important, both to the speakers and to the people that run the event. Because if you don't like somebody, rate them that way and they may not come back. All right, we're going. Welcome, everyone. I appreciate you giving me your lunchtime. This is MGT 306. Tips and Tricks for Creating Custom Management Packs from Microsoft System Center Operations Manager. A very long title. My name is Mickey Gousset. I am a Principal Consultant for Infront Consulting Group. Here's my contact information. There's my email address. This information is also in the slides. You're more than welcome to send me an email if you have any questions. You can also find me on Twitter. Now, I'm a weird person in that I'm actually a developer working in an IT pro world. So I'm a Microsoft Application Lifecycle Management MVP. So I do a lot from community work with Team Foundation Server, with Visual Studio, with Application Lifecycle Management. But my day job, I work for Infront Consulting, who does System Center consulting and training. Specifically, I do SCOM Management Pack development, I do Service Manager, and I do Orchestrator. But Management Pack development is where I got started and is still kind of my first love. I've got a couple of websites that I blog on and a podcast that I co-host if you're interested in the ALM side. I've written a couple of books, which I'll be happy to tell you about afterwards if you have any interest in that. But here's our agenda for today. This session is about tips and tricks for being able to build custom management packs for SCOM. So the idea is for you to walk out of here with some things that you can take back and start applying in how you do things when you build custom management packs. So we're going to start off with a basic introduction to the management pack structure and look at how it is an XML file and look at some different tips and tricks around modifying that XML file. We're going to look at the tools you can use for building management packs. That's going to be relatively quick. Then we've got 3 sections to cover. Basic tips, which are things that you're going to do almost every day when you're building management packs. Advanced tips, which are things you may use once you get comfortable building custom management packs. And then some expert things, which even I and other people, when they use these tips, have to go back and research. So when we get to the advanced and expert stuff, even if it doesn't initially make sense, hang with me. Because it's stuff that you'll want to know exists in case you want to use it in the future. So that's the basic agenda. As I mentioned before we started, I'm assuming everyone in here knows how SCOM works, that it's a workflow engine that basically does monitoring. I'm assuming that you've probably maybe even built some management packs, either with the authoring tool or with the authoring aspect in the operations console. One other thing I'll point out, and if you've done management pack development, you understand this. To show some of these demos, I have to actually import the management pack into SCOM. So once I import it into SCOM, I'm at SCOM's mercy when it finally decides to recognize that management pack, push it out to the agent, and for the agent to actually process the management pack so that we can see the results. So we may do a little jumping around. If I'm having to wait for SCOM to finish processing, I'll move on to another topic and we'll come back. So given that, management packs. Management packs in SCOM are how you add functionality into SCOM. At the basic level, we're building classes. We're deciding what we want to monitor. We build a class that models that. Then we have to go out to our servers, to our computers, discover that class. Once we've discovered that class, then we can create the monitors and the rules to determine if that class is working correctly. And if it's not, throw alerts or change state. But a management pack at its core is an XML file. How many people in here love XML? Oh, you lie. XML is not bad. But it is an XML file. It has a schema associated with it, and it can be quite complex, depending on what you're trying to accomplish. Since it is just an XML file, you can edit it with Notepad, or you can edit it with a variety of tools. But now we're going to complicate it a little bit. There's two types of management packs, sealed and unsealed. An unsealed management pack is simply an XML file. It has a .xml extension, and that's what you're editing when you initially start creating a management pack. You can import an unsealed XML management pack into SCOM, and it will work just fine. However, if you've downloaded management packs from Pinpoint or from Microsoft, you've noticed they have a .mp extension on them. Those are sealed management packs. Those are XML management pack files that have been turned into a binary file by using a key. Why do you sealed management packs versus unsealed management packs? Most people, if you're selling a management pack or giving a management pack away, when I give you a management pack and you import that into your environment, I, as the person that built it, want to make sure it works the way I designed when you initially import it. So by giving it to you sealed, you can't edit it. You can't edit it because it's a binary file. You can create overrides, right? We can override thresholds on different management packs. But remember, when we do that, we have to store those in what? An unsealed management pack. Some people think that because they seal their management pack, they're protecting their intellectual property. That's not true. Because I'm going to show you how you can take a sealed management pack and with a couple of PowerShell commands, turn it into an unsealed management pack. This is the best way to learn. If you want to see how Microsoft or other people have built management packs, you can take the sealed management packs, export them as unsealed management packs, and then open them up in Notepad or whatever editor you want to use. And I'm going to show you how to do that. So given that, let's actually look at some basics around management packs. So I've created a simple management pack here, which is I created a brand new blank, empty management pack in the authoring tool. And if I open that with Notepad++, anybody in here use Notepad++? Oh, great. I love Notepad++. Then here, let's blow this up a little, is a basic empty management pack. Some basic tips you need to know right now. Management packs have an ID value. The ID value has to match the file name. So this ID value of the management pack, in the management pack has to match the management pack's file name. If it doesn't match, you will not be able to import the management pack. It will not import. So that's definitely something you need to know. Another tip you need to know is management packs have version numbers on them. Best practice, anytime you change your management pack, you should update the version number. Updating the version number is going to allow you to keep track of all the changes you make to your management pack. And we're going to talk about version control as well in a moment, so that you can keep track of all the different files that you're changing in relation to your management pack. Management packs can reference other management packs. That's what we're doing here. Why do I want to reference another management pack? Maybe I want to create a monitor or rule that targets a class in another management pack. So therefore, I have to add a reference to that management pack. Here's the key. You can only reference sealed management packs. So when you try to create a reference, if you try to create a reference to an unsealed management pack, your management pack will not import. You can only create references to sealed management packs. So that's another reason you would want to seal your management packs, is if you need to reference them in other management packs. And then the only other thing that was created in this basic empty management pack was the language packs area. Now the language packs area is really cool, because this is where you control localization. So what happens is, all the display strings, like names and descriptions that show up in the operations console, are stored in the language pack section and are tied back to different elements in your management pack using an ID. So in this case, you can see I'm using English language, and here's my name, and here's my description. If I want to localize my management pack to work in multiple languages, I can simply copy my language pack section, add it underneath, change my ID value to be whatever language I want to use, and then change my names and my descriptions to be the appropriate values in that language. Your management pack is now localized. A lot of people don't grasp what the language pack area is for, but that's what it's for, to make it easy to localize your management packs. Now, I mentioned to you before that you can't export sealed management packs. Now you'll notice here I am in the operations console, and I've got a list of management packs here, and some of them show up as sealed, some of them show up as unsealed. If I right-click on a sealed management pack, I can't actually export it. However, you can use PowerShell to do it. So you can use the following command in PowerShell. You can say get-sc management pack. This changed in 2012. In 2010, it was just get, or 2007, it was get-management pack. In 2012, it's get-sc management pack. That gets all the management packs. Then I can pipe that into the export SC management pack. So it takes each management pack and exports it into whatever directory I specify. So I'm going to come out here to my computer, and we'll create a new directory here called MP Backups. We'll open it up. You'll see that it is empty. I'm going to copy my line of code. And I'm going to run that. And we'll open this back up. And what we should see in about, 15 seconds or so, is a bunch of management packs showing up in here. But what's cool about this is they're all going to be unsealed. Because when you export the management packs using the PowerShell command, it exports them in an unsealed format. Still running. There you go. You can see. Lots and lots of management packs. And notice the sizes. Some of them are very small. Some of them are rather large. If you open up this rather large management pack, again with Notepad++, we have our manifest section with our references. But then we also have some new sections, like module types, where we have these data source module types, which you're going to learn about a little bit later. We have custom unit monitors, which you're also going to learn about. Our categories, this is where our rules are specified, our tasks, our monitors, our diagnostics, our recoveries, overrides we specified, presentation section, language pack section, resources section if I've built some custom DLLs or I have custom images I want to load. I show you this to show you that management packs can get really, really big. As you can see, I'm on line 43,628. Building management packs is development, so it's just something to keep in mind. So, the basic idea around this in general is to create classes, discover those classes, then create our monitors and our rules. Well, to do that, we're going to need tools. Tools that you can use for building management packs include the following. If you're building management packs for SCOM 2007, there's the authoring console. And actually, you want to download the resource kit. There's a resource kit that includes the authoring tool. It includes a best practice analyzer, a workflow analyzer, a simulator. It's a great, great source of tools. And that's what we'll be using today. If you're going to build management packs for 2012, you can use the 2007 authoring tool with some caveats. It doesn't do 2012 specific features. So all the specific dashboarding and things like that in 2012, it won't do. And if you build a 2012 management pack using another tool, you can't open it with the 2007 authoring tool. So how do you build 2012 specific management packs? You've got the operations console, which of course is just the wizard in the operations console. But you've also got brand new extensions for Visio and for Visual Studio. So the Visio extensions allow you to drag and drop and create a Visio diagram, linking things together. You save that, export it, it creates a management pack. The Visio diagramming is great for basic management packs. For more complex management packs, you have to go the Visual Studio route. So there's extensions for Visual Studio that allow you to use Visual Studio to create management packs. Those were supposed to be released but have not been officially released yet. They should be coming out soon. But in my mind, nothing does better than a text editor. As you've seen, I like Notepad++. Any good text editor or XML editor will do. So those are the different tools that you'll have. Can you hold that till the end? Because don't write it down. Don't forget it. But I'm pushing. I want to make sure I get through all my content. Hold that for me, though. I don't mean to be rude. So, excellent. Thank you. So, with these tools, now that we've got the tools and we've got the basics of management packs, let's talk about some different tips and tricks you can use for building these management packs. Now, I've taken the first 2 days of my course and tried to distill it down into this. So these are some things that I've encountered both in the real world building management packs for customers as well as building internal management packs for things you need to consider. And that's targeting. That's aspects of your management pack design. Version control. We'll talk a little more about ceiling management packs. But then we're going to talk about discovery scripts. Because there's a couple of gotchas in discovery scripts that people don't know. And then we're also going to talk about customizing your rules and monitors. And specifically, something that I'm always asked to do, which is making a rule only run during business hours. And doing that will lead us into our more advanced topics. Targeting. When you create a rule or a monitor, you target it at a class. Okay? It's very important that you target it correctly. So, for example, in this scenario, we want to monitor failed logon attempts on Windows Computer. Okay? So I'm going to create a monitor that monitors for failed logon attempts. What do I target that at? Well, it depends, of course. For me, logging into Windows is an operating system thing. So I'm going to target Windows operating system. So by targeting Windows operating system, I'll target all my desktops and all my servers. If I want to be more specific, I only care about failed logins on a server, I can target Windows Server operating system. That way I leave my desktops alone. If I only want to target 2003 servers, for those of us that still have them, then I can target Windows Server 2003 operating system. I could also target Windows Computer, but in my mind, logons are more of an operating system aspect. Those are all good examples of targeting. Bad examples of targeting that I've seen in customers are they target the SCOM agent. Targeting the SCOM agent would be bad for two reasons. First off, if you're doing agentless monitoring, then the system that doesn't have the agent on it is not being targeted. But the more important reason is, let's say I discover failed logons and I change the health state in my monitor. I'm changing the health state of the agent, not the computer. So I'm giving a false indication that the agent is in an unhealthy state when it's actually something with the computer or the operating system. So that's why your targeting always needs to be exactly specific. I also would not target computer, just basic computer, because basic computer means that I'm targeting both Windows and non-Windows computers, which means it could target Unix or Linux, and I don't know what my monitor is going to do. Targeting is very important. Here's the basic model for operating systems in SCOM, which is you have an operating system class. So classes in SCOM use inheritance. So all classes have a parent. So the Windows Server operating system class is parent, is the Windows operating system class. The Windows operating system class's parent is operating system. So all classes have parents. The thing to know about targeting rules and monitors is when you target a parent, it also targets all the children and subchildren underneath. So if I target a monitor at Windows operating system, it targets Windows Server, Windows Client, and each of the children underneath there. If I target just Windows Server, it targets Windows Server and all the children underneath. So you need to be aware of the hierarchy of the classes that you're targeting, because you don't want to push a monitor out to a bunch of agents and a bunch of servers that don't need it. All you're doing there is taking up processor, taking up cycles. You only want to push your monitors, your rules, to the places they need to go. So your targeting needs to be as specific as it can. Another thing to consider when building management packs. Do I build one big management pack with all my classes, all my rules, all my monitors? Or do I build multiple management packs? One for my classes, one for my rules, one for my monitors. How many people think you build one big management pack? All right, I got one person. Okay, brave man. No. How many people think you build multiple management packs? How many people think it depends? Wait, some people raise their hand twice. It depends. You can do it either way. Pros and cons for both. One management pack, it's all in one file. That makes it easy to move up and down, find what I need. Unless my file is 100,000 lines of code. Then it becomes a little more difficult. Usually if I'm building a small, simple management pack, I will go with one file. Multiple files works great for larger management packs, because if I need to add a new class, I just go to the classes management pack. If I need to add a monitor, I go to the monitors management pack. However, if I have a monitor that wants to target a class in my classes management pack, what do I have to do to my classes management pack first? Seal it. Exactly. So that adds an extra step. Now, sealing a management pack takes 15 seconds. But it is an extra step in your process. So it's something to keep in mind. If you're going to use the multiple management packs, in order to reference the classes, it has to be sealed first. Some people find that a little aggravating. I find it cost of doing business. Developing management packs is development. All right? You're building a bunch of files, or one big file, and you're going to be making changes to that. So you need a way to track those changes. So that's where you need some sort of version control system. Now, you can use Microsoft Team Foundation Server. And if you're going to build management packs using the Visual Studio extensions, that's a great solution, because it integrates into Visual Studio and you can check things in and out. There's other third-party version control systems you can use as well. But at the end of the day, you need to use something. Honestly, for about 60 or 70% of my development, I use what I call my poor man's version control. So here's my poor man's version control. Where's my mouse? There it is. I use file folders. So I create a file folder that's the name of my management pack. And then I create a version number folder that contains that particular version. So if I need to now work on version 1.2, I could just copy that, paste it, rename it, and now I can start working on version 1.2. This is important because if you make changes, if I start working on version 1.2 and I mess something up badly, I want to be able to roll back. So I want to be able to go back to what I started with. This leads to another tip. When you're editing or building management packs, you should build them incrementally. So add a class, add a monitor, test it. Then change the version number, add another monitor, test it. Don't create 50 classes, 50 discoveries, 200 monitors, and then import that into SCOM and hope that it works. Because chances are it's not going to work, and then it's going to be a lot harder to debug. And if I'm building things incrementally, even using this folder structure, I'm able to track the changes that I make. That is very, very important that you can roll back to your previous changes. Very, very important. Discoveries. So, we build classes, right? We build and we define our classes, then we have to find those classes out in our environment. And finding those classes is done using discoveries. In SCOM, you can do registry discoveries. Those are the best. You should use registry discoveries first if you can, because they're fast and they're easy and they're cheap on performance. You can do WMI queries. How many people in here have used WMI? How many people in here have had to deal with corrupted WMI databases? There you go. That's the catch with doing WMI queries, is the potential for the databases to be corrupt. But you can do WMI queries. However, if registry or WMI doesn't quite do what you want, you can write a script. Awesome. So I can do VB script. I can do PowerShell. Scripts are great. Scripts are powerful, right? Scripts, we can do anything. That's also the problem. With scripts, you can do anything. So you've got to be very careful with your scripts to make sure you test them and make sure they work the way you expect them to. So what I'm about to show you, though, is discovery scripts are all the same. I'm about to give you a template for a discovery script that you can use for every discovery that you're going to create from here on out. That's written in VB script, but it's still good. The first thing you have to do is set up the objects. So I have to create an API object, accessing the SCOM API, which is referred to as mom.script API. Then I have to build a discovery data object. That's the object that holds my discovery data. Now, the discovery data object has 3 parameters. The first one's always a 0. It's always a 0. That's a throwback from Mom 2005. It's just a 0. Set the 0 and move on. Then we pass in 2 other values, source ID, managed entity ID. Hold on to those. I'll come back and explain them. Now, once I create these 2 objects, then I add my business logic. This is where I'm looking at log files, looking at INI files, querying databases, doing whatever I do to determine if the class exists. If the class exists, I create a class instance. So I use the discovery data object, create a class instance. I replace class name with the ID value of the class. If my class has properties, I add a property to the class by saying class name / property. And where value 1 is, I replace it with the property. And once I've finished creating that instance, I add it to the discovery data. And finally, I return the discovery data. Because if I don't return the discovery data, nothing's going to happen. That's your basic discovery scripts. All discovery scripts look like that. So, what is this source ID and managed entity ID? Source ID is the workflow ID, the GUID value of the discovery that's running. So SCOM has a GUID value it associates with that discovery. It's the GUID value of that discovery. And you access it using that variable, $np element $. So you can pass that into your script. Managed entity ID is the ID of the object you're targeting. So that discovery targets a class. The GUID value of that class is the managed entity ID. And you access that by saying $target, the class I'm targeting, / the value of the class, which is the ID value. So when you create a discovery script, you're always going to pass in $np element $. You're going to pass in $target / ID $, and SCOM will turn those into what it needs to be. So some tips around your discoveries are you should always return a discovery data object, even if it's empty. Okay. Here's why. SCOM keeps track of what discoveries found what objects. So if I install an application on this server, and I discover that application, SCOM starts monitoring that application. I uninstall the application. The discovery runs again, and returns nothing. SCOM realizes that, well, that discovery should have returned a class. It did not. So I'm going to remove that class from SCOM, and we don't have to monitor it anymore. If you don't return a blank discovery object from your script, SCOM doesn't know that things aren't there. And you'll actually get an error in the event log. So you always should return discovery data. You should also target as specific as you possibly can. Goes back to my targeting argument. Discoveries can be intensive, so you don't want discoveries to run on systems any more than they have to. That leads into how often should discoveries run. So if you're testing a discovery, how often should it run? Anybody? Every 60 seconds, every 30 seconds, whatever. As short a time as you can take it so you don't have to wait, right? Because you got better things to do. In production, best practice, discovery should run once a day. At best, discovery should run every 4 hours. Unless you've got a really good reason to have a discovery run more than that, then it should run maximum every 4 hours and best practice once a day. Now, how do you debug these discovery scripts? That's the fun part. There's not necessarily a good way to do that, but we're going to look at, when we talk about rules and monitors, how we can make use of this log script event, which is something you can add in your script that writes to the event log, the operations manager event log. So you add a bunch of log script events into the operations manager, into your script, so you can track where you are in your script, is the best way to debug these. And I'll show you how to do that here in just a moment. So the last thing I want to show you, though, from a basic tip perspective, is making a rule, an alerting rule, only run during business hours. So this is something I get asked all the time. I get asked, create me a rule that monitors a log file. And if it finds an error in one of the lines of the log file, it throws an alert. How many people have done that? It's pretty easy, right? Now, they come back and say, okay, but I don't want it to throw alerts after 5 p.m. I only want alerts during business hours. That it doesn't do out of the box. But remember, SCOM's a workflow engine. And behind the scenes, it's made up of all these different modules. So you can actually mix and match these modules together to be able to build your own custom monitoring. So that's what we're going to do. So if I come out here to my authoring tool, so this is the 2007 authoring tool, and I open up my rule, I've already built a basic management pack for just monitoring log files and throwing an alert. So I've already created a rule. And if I open up that rule and go to modify it, then you'll notice that it's made up of two different modules, a data source and an action. But I also have this condition detection in here. So if I look at the data source, it's a generic log file monitor. And if I edit that, then I can see that I'm monitoring the demo4 directory, and I'm looking for demo4.log, the log file. Great, makes sense. And I want to check each line of that log file to see if it has the word error. Now, how you do that, edit that, figure. To access the line of the log file, this used to be arcane, now it's documented. But to access the line of a log file from a log file monitor, you say params/param, open bracket 1, close bracket. That makes sense, right? And what I'm saying here is the line from that log file contains the word error. Now, if the line from that log file contains the word error, I want to generate an alert. As you can see, I can actually pull the line from the log file and put it in the alert by saying $data/param/param1. Now this works. Most of y'all have built these log file monitors before. Now if I want to turn this into something that only runs during business hours, I've got to determine, how do I know if it's during business hours? Well, that's where the condition detection happens. So there's like I said, SCOM is made up of a bunch of different modules. One of the modules that's available to you is the schedule filter module, which allows you to filter the schedule. Makes sense? When I first started building management packs, I would come in here and I would select this module, and I wouldn't understand why I couldn't click OK. That's because you have to give the module some sort of ID value. So I'll call this my schedule. Now I need to configure it, so I'll click Edit, and that doesn't help me. But luckily I have a Configure button. And this is where I can control when the alert fires. So I can say always process the data from the data source. Or I can say only process it during a specified time. So this is what allows me to say I only want this to run. Let's say I only want it to run on Fridays. So the only time I care about getting alerts from this log file is on Fridays. That's all I have to do. I could come in here and exclude specific days. And by doing that, I've added a condition detection to my rule. So the log file is going to run. It's going to read from the log file. It's going to, as it finds errors, it's going to check. Is it Friday? If it's Friday, it's going to throw an alert. If it's not Friday, it's going to throw that line from the log file away and keep reading through the log file. That's something to keep in mind. It doesn't store it up and then say at 8 on Friday, send me 20 alerts. It just skips all that information. But for this particular client, that's what they wanted to do. So let's save that. And I'll change my version number. I'll say that one more time. And let's import this into SCOM. So to import management packs, I can right-click, Import Management Pack. And I will say, go back up here to modifying my rules. So I'm going to import that into SCOM. So here's the thing. When I'm building management packs, obviously I'm importing into my test system, and then those are being pushed down to the agents that I'm testing on. But how do I know when that management pack has actually been pushed down to a particular agent? And how do I make sure I force it to go down? Because as any of you may have experienced, sometimes SCOM can take a while before it actually pushes a management pack out. So, a quick tip. If you want to force an agent to make sure it has the latest management packs, stop the agent service and start it again. By stopping the agent service and start it again, when it starts back up, it will go to SCOM and say, do I have the latest of everything? And if it doesn't, it will pull them down. Another way to tell if you have the latest of everything is through the Operations Manager event log. So if you go under Event Viewer, Applications and Service Logs, there's an Operations Manager event log. And my system is running slow. Give me just a moment. The management packs are going to write out to the event log when an agent receives them. So the two events you want to look for are 1201. The 1201 indicates that the agent has received the management pack. Now, just because it's received the management pack doesn't mean that it's using it yet. It still has to go through and process it and determine what to do with it. So after the 1201, you want to look for a 1210. New configuration became active. So when you want to make sure, if you have a system you're trying to monitor, and for some reason it's not being monitored, you want to make sure the management pack has been pushed to that system. You can look for the 1201 and the 1210. You can force it by stopping the management service and starting the management service back up. But as we saw in the authoring tool, this rule, if you've walked through the wizard for building these rules, you don't see all this. you don't see data source condition detection write action. It has a couple of tabs that you fill out. But behind the scenes, everything in SCOM, monitors, rules, workflows, discoveries, are made up of these different modules. So we're about to talk about that and show you how you can build your own custom modules and why you would want to. So, everybody's passed the basic test. Now on to the advanced. First thing we're going to talk about are some of the concepts around this. Keep in mind, when I teach this, this is a whole day session. So some of you may get it. It may seem a little strange to some of you, but it's still stuff you need to know is there. So stick with me. But we're going to talk about advanced authoring concepts. And then we're going to look at how we can build our own custom data sources. And how we can build our own custom unit monitors. And why we would want to, why that's important. So behind the scenes, everything is a workflow. Discoveries, rules, monitors, diagnostics, recoveries. Everything is a workflow. There are rules for how these workflows go together. A discovery is built out of certain modules. A rule is built out of certain modules. You have 4 modules to choose from. Data sources, which, as you would expect, get the data. Probe actions, which allow you to go retrieve more information based off of specific criteria. Condition detections, which we've already seen, they're an if-then-else statement. If it's Friday, keep processing. And then we have write actions, which are things like generate alerts, or write to the database, or write to the data warehouse, or kick off a command line application. There's lots of different actions there. And you have a lot of these modules out of the box. Now, honestly, most of the ones that are out of the box, you're probably not necessarily going to use inside your custom. There are only probably about 15 or 20 that you'll use. But you do have all these different modules available to you, and you can build your own. And when you're building your own, you're not writing C# code, you're not doing anything like that. You're writing XML. Maybe some scripts, but it's all XML. If we look at how a rule is set up, a rule has 1 or more data sources, 0 or 1 condition detections, and 1 or more write actions. Now remember, when we created our initial rule earlier, it had a data source and a write action, but it had no condition detection. I added a condition detection. The catch is, I can't add a second one. I can only have 1. And the authoring tool actually enforces that. So you can take these things but what this allows me to do is, because it's modules, I can put these different modules together to build my own custom monitoring solution. So here's a scenario that I did at an actual customer that I want to show you the solution for. We've looked at log monitoring, correct? We can monitor a line of a log file, and if I find something in that line, I can throw an alert. And in the alert, I can include the line from the log file. What if I only want to include a portion of the line from the log file? Anybody ever needed to do that? So I have a customer that has a log file that looks like this. It's got a date time with a pipe symbol, a counter with a pipe symbol, and the counter's value. What the customer wants to do is monitor this log file for a specific counter. If they find the counter, they want to compare the value to a specific value. If the counter is greater than that value, throw an alert. I can't do that with the generic log reader in SCOM. Because in the alert, they only want to include the counter name and the counter value, not the line from the log file. I can't do that with the generic log reader in SCOM because the generic log reader in SCOM doesn't allow me to break that out. So I sat and I brainstormed, and I said, oh, I've got a great idea. I'll just write a script. Because scripts, we can do anything. Anybody real quickly see a drawback for using a script for reading this log file and doing all my processing? How do I know where I am in the log file? The generic log reader in SCOM is awesome because it keeps track of where it is in the log file. If I wrote a script to monitor this log file, I would have to somehow maintain state and keep track of where I am in that log file, so I'm not reading the whole log file every time. I could do that. I wrote a script to do it. You actually have to write things to the registry to maintain your state, and it was bad. Then I had an epiphany. And I said, what if I could use the generic log reader to read the lines from the log file, but then pass each line into my script and let my script process that line? And that worked. And I'm going to show you how that works. So, come back over to my authoring tool. Now, here's the thing. I have multiple counters that I want to monitor. But I don't want to copy my script multiple times into multiple rules. So I decided to do this using a custom data source. I'm going to build a custom data source that uses the log reader plus my script to get the information, and that can be used in multiple rules. Then, if I need to update my script, I only change it in one place, the custom data source, as opposed to changing it in 20 different rules. So let's look at how I build the custom data source first. Over in the authoring tool, in the type library section, I've got a modules type where I can build my custom data source. So if I open up the custom data source that I've pre-built, on the members module is where I need to add the different modules that will make up this custom data source. And there's two modules. The first one is the generic log reader, because that's what reads in the file. And if I look at the generic log reader, now remember, this is a data source. This is going to be used by a rule. In the rule is where I specify monitor this file in this folder. So in the data source, I need to provide parameters so that you can fill out the rule. To provide parameters, I say, let me blow that up, $config / parameter name. So I've created two parameters here, one for log file directory, one for log file pattern. This reads a line from the file. Now I want to pass that line from the file into a script so I can do my processing. So I've used what's called a script property bag probe. This is a script that I've written that returns what's called property bags. Property bags are variables. They're parameters, name value pairs. That's all they are. I have a script that returns this property bag so that the rule can evaluate the property bag to determine if it needs to throw an alert. Now, if I look at the configuration for the script, then it looks like this. I've got to configure the script name, so I'm going to let the user determine what the script name should be. I've got arguments that I have to pass into the script. Arguments that I have to pass into the script include, I want to pass the script name in. I want to pass the line from the log file. I'm going to take the line that the log file reads and pass it as a parameter into the script, where then I can parse that line from the log file. I'm going to let the user specify what counter they're looking for, what the error value would be, and then I also have a parameter here called debug. I'm going to show you a tip that I always do in all my scripts that allows me to turn debug information on and off in the scripts. So that I can turn debugging off when everything's working, but I can turn it on when it's not. I've got my script, which I'll show you in a second, and my timeout values. Now, since I've said that I've got a log reader plus a script probe, I'm going to have the log reader be first. The next module is the log analysis script probe, which then will provide output. So if I had multiple other modules, I would have to specify which one followed which. I declared all those parameters. So now I've got to specify the different parameter types for each of those parameters. Are they strings? Are they integers? Are they date times? Here's the cool thing, though. I can specify which parameters can be overridden using the Override Parameters tab. This is why in some monitors you can override some values and in other monitors you can't. Because the people that created the monitors only let you specify certain parameters for you to be able to override them. Now I'm a fan of letting the user do what they want. So I let them override everything here. But that's why that's the case. And you'll need to decide when you build custom monitors like this with parameters what you want the user to be able to override and what they don't need to override. And then finally, my output is a property bag, which it defaults to. So that's my custom data source. Now, I still have to add my script into my custom data source. Now, to do that, I like to actually go into the XML and do that. But first, let's go look at this actual script so I can show you what it does. So here's my script. And it creates the API object, creates a shell object. I create a property bag. So I create a property bag object to store all my property bags. I get the arguments that are passed in from the script, and I check to see if I have 5, because I'm expecting 5. If I don't have 5, I'm actually going to throw something to the event log that says unknown script name with a description, or unknown script name. I'm going to say it's got a value of 5,000, and it's the wrong number of arguments. And then I'm actually just going to quit. But if I have the right number of arguments, I'm going to set those into different variables. And I'm also going to set this turn on debug value. And then you notice I have all these debug outputs. That's because I've actually created this. I do this in all of my scripts. I create a debug output function. What this basically does is, if debug is turned on, then either if I've got it uncommented, I can write to the console, or I can write to the event log. Writing to the console is great when you're testing your scripts from the console. Writing to the console does not work in an actual management pack that's in SCOM. In that case, you would want to comment those out and uncomment the log script event. The reason I add this to all of my scripts is so that if a script does not work the way it's supposed to, I can turn on debugging to see what's happening, and I have these debug statements inserted throughout my script. As you can see, I've got debug statements there. Here, I'm taking the line from the log file, and I'm splitting it into those 3 pieces. Then I'm checking to see if that line from the log file has the counter we care about. If it has the counter we care about, I check to see if the value of that counter is greater than my error value. If it is, I create the following property bags. I create a variable called result that has a value of error, and then a line from the file, which is the line from the file. And then I have the counter name and the counter value. If it's not the right counter, or if the error value isn't what I care about, I just set result equal to blank, because I don't care about that line. It didn't match my counter, or my condition was less than the error condition. And finally, I return this property back. So, I want to test this script. But I want to test this script without importing it into SCOM. Right? The best way to do that is to run the script on a machine that has a SCOM agent. That's because you're accessing the SCOM API up here. And I've got different API calls. What's cool, and here's another tip, if I run this on a machine that's accessing that has a SCOM agent, I'll actually see the XML output, the XML data that's going to be passed back into the rule. So let me show you. Oh, and here's another little tip I learned at TechEd last year that I didn't know. If I have Windows Explorer opened to a particular folder, if I just come up here to the taskbar and type CMD, it opens up a command prompt to that folder. I didn't know that. I thought that was cool. So I want to run this script and test it. So I'm going to say C script, and my script name was custom source. And I have to pass in the different values. I'll blow this up in a second. So the different values would be my script name. So we'll say it was going to be called test.vbs. I need to pass in a line of log data. So that would be some date time value, followed by some counter, followed by some counter value. Then I need to pass in the counter I'm looking for. So I'm going to say I'm looking for counter 1. Let's say I only want to trigger an error if it's greater than 25. And I want to turn debugging on. So I write out those statements. So I'm running C script. I'm saying run this script and passing in the different parameters to the script. These are all the output statements from my debug output method. But this is the XML data item that's going to be passed back, that's going to be used later on in the rule, which contains things such as a property named result that has a value of error because we're less than, our value of the counter is greater than 25. You can see we've pulled out the counter name from the script. And we've also pulled out the value from the script. Now, if I rerun this and change this to be 90, then you'll notice that the result returned a blank. The script is working the way we expected. This is nice because this actually shows me the XML data item that it's going to be passing back into the rest of the rule. Now, I need to add this script into my management pack. When you add this script into your management pack for a custom data source or a custom unit monitor, you want to do it directly in the XML, not the authoring tool, because you want to find the script and you want to wrap it in a CData tag. That CData tag is an XML thing. It stands for character data, which means that anything inside the CData tag, it's not going to replace the XML. For example, replace your ampersands with AMP semicolon. Replace your greater than signs with GT semicolon. Because that can screw up your script. But you add your script into your data source. So what this allows me to do is I now have a custom data source that's going to read this log file, pass each line of the log file into my script, which will process it, and then will pass the property bags to whatever else is going to happen. Now that I have this custom data source, let's actually look at the rule that uses this custom data source. So under Health Model, I've already created a rule. And if we open that up, I've got a data source that is the custom data source. And if I go to Edit, there's all my parameters. So I can build this custom data source and then give it to somebody else who doesn't know how the script works, doesn't know how it works behind the scenes. All they have to do is specify the parameters. So in this case, I'm monitoring demo 5 for this log file. If I find counter 1 and the value is greater than 75, I want to throw an alert, is my goal. That data source returns property bags. Now I need to take the property bags, take what was returned, and determine, am I in an error state? How do I know if I'm in an error state? If that results property bag has the word error in it, I have a problem. So I'm going to click Edit. So what I did is I added an expression filter, which allows me to create the following expression, which says, if a value in the property bag that's passed into this expression filter, if there's a property bag that has a name of result, and that name and that result equals the word error, do something. So I'm scrolling through the property bags that were returned and saying, was an error returned? If it was, then generate an alert. And in generating the alert, I can do things such as access other property bag information. So I'm accessing the counter name and putting it in there. I'm actually accessing the line from the file that I passed back as a property bag. I could also pass back access the counter value because I passed that back as a property bag. So I'm able to take the line from the file, and because I parsed it in my script, I can then include different pieces in my alert. Now, you'll notice that in my alert configuration, I have debugging set to true. So if we test this, we should see some things written to the event log. So let's see what happens. So I've already got this loaded up. So if we go over to monitoring and active alerts, hey, look, I keep my SCOM system pristine, no active alerts. We're going to go to demo 5. And I'm going to add actually, I don't want to do that there. Let's do this. Let's get a line from my log file. And we'll go to demo 5, open that up. I'm going to add in a line. And my alert condition was 75, so I'm going to set this to be 90. Now, here's the thing about log file monitors, another tip. They don't actually read a line until there's a carriage return line feed at the end of it. Found that out the hard way. So if there's not a carriage return line feed, it will not pick this up until there is one. So I'm going to put a carriage return line feed, and I'm going to save this. Now, SCOM decides to play nice. Boom, a bunch of 5,000 messages. So this is where that value was read. Started my script. It read in the line from the log file. As you can see, it's that line that I just changed to be 90. So I'm able to see where I am in my script and that my script ran correctly. And if I go back to monitoring, I now have an alert. And if I open up that alert, I've got all the information. So I can take that custom data source and use it in multiple rules. If I ever have to change the script, I change it in one place. Now let's take it one step further. I want to not just throw an alert, but I want to change state. I want to go critical if this happens. To do that, I have to have a monitor, because a monitor is the only thing in SCOM that can change state. So I'm going to using this same premise, create a custom monitor. Now, I can use my custom data source to power my custom monitor. So let me show you. So we'll come out here. If I go to type library, I've still got my same custom data source, but I've also got my monitor type that I've created. If I open that up, Here's my custom unit monitor where I specify I can make a 2-state or a 3-state, so I can be healthy or critical is what I've decided. And then I specify the different member modules that will make this up. In this case, I'm using my custom data source, where I'm still specifying parameters because I'm going to specify parameters in the monitor that people can use to configure this. But I also have to have 2 condition detections, one that detects a healthy expression and one that detects a critical expression. My healthy expression checks for a property of result that equals healthy. My critical checks for a property of result that equals error. Just like we did before, we're looking for the word error. Now, I have to specify for my healthy and critical which modules to process. So if I want to check my healthy condition, I check my data source, which then flows into my healthy expression. Then I have to click my critical condition and specify my data source and my critical expression. I specify my configuration and overrides just like I did before. This now gives me a custom unit monitor type, which allows me to come up here into my health model and create a monitor type that uses that custom unit monitor, where all I do is configure those parameters. So now I'm doing the same thing, using the same script, using that same script that the rules used, but I have a custom unit monitor that I can give to other people to say, here, build your monitors using this. And I only have to change my script in one place. So this is some of the more advanced stuff you can do when you start building scripts and start putting these modules together and start building custom data sources and custom unit monitors to monitor your specific conditions. Now, expert stuff. We're going to talk about this at a kind of a high level, but it's important. 3 expert things you need to know about: cook down, on-demand detection, agentless monitoring. The number one thing to know is cook down. What I mean by cook down is this. If I have 20 different rules, well, let me back up. Rules and monitors are workflows made of all these modules. If SCOM detects that multiple rules are using the same module, it will actually just run those modules one time and then pass that information to all the different rules. There's some conditions around that, but that allows you to be more efficient. An example of cook down, real quick. I have a custom monitor that's made up of a data source, a probe, and a condition detection. I have a second custom monitor that uses a custom data source and a condition detection. And I have a rule that uses that same custom data source, a condition detection, and a write action. And finally, the custom data source is actually made up of that simple scheduler, custom probe results, which are, if you'll notice, exactly the same as in Custom Monitor 1. So what SCOM does when it starts breaking these things down to determine how to run these different workflows is it actually replaces all the modules with simpler modules until it makes a big long chain. So if we take these 2 monitors in rule and break them down, then you'll see that the first monitor is the data source probe condition, the second one is data source probe condition, and then another condition, and the rule is a data source probe, 2 conditions, and a write action. But look vertically. That first data source is all the same. They're all using the exact same data source. They're using the exact same custom probe and the exact same condition detection. SCOM is smart enough to go, oh, they're using the exact same modules. So when those things run, I'm just going to run it once instead of 3 times and pass that information into the rest of these rules. Some caveats. When you do this, your parameters into those different modules have to be exactly the same. So any parameters you pass in, how long they're going to run, they have to be exactly the same. If they're not, then cook down won't work. But the reason cook down is important is, like I said, if I can take 200 rules that I have and power them from one data source, I'm saving cycles, CPU time, all sorts of things. So when you start building really complex scripts, or scripts that you're going to use in multiple rules or multiple monitors, you need to consider this cook down factor, and how do I make sure these things cook down correctly? Come back to that. Another thing I want to point out too, if we have time, is on-demand detection. Okay, Health Explorer. How many people in here have used Health Explorer? If you use SCOM, you use Health Explorer. How many people in here have selected a rule that's in red and clicked recalculate health, or monitor in red and clicked recalculate health? And how many people have said, is it doing anything? There you go. That recalculate health button isn't going to do anything unless the custom unit monitor has been built to handle it. And there's certain rules and certain ways that the monitors have to be built to handle that. One of the nice things, if they're built that way, is that if you put something into maintenance mode, when you take it out of maintenance mode, it'll automatically recalculate health. If you click that recalculate health button, it will automatically recalculate the health. But there's certain ways you have to build these things, which is your custom monitor, your custom unit monitor, can't start with a data source. It has to start with a probe. And that's just a rule and a value. Another thing to consider, though, if you're going to enable your monitors where they can do the health recalculation, this on-demand, is how many instances of a class are you going to have that it's going to try to automatically do on-demand recalculation on? Because if I've got 200 instances of a class on this machine and it starts to recalculate for all 200 instances of that class at the same time, depending on my script, I could impact performance on that machine. So just be aware of that's how the recalculate health button works. That's why it doesn't always work when you click it, is because the monitor isn't designed that way. Finally, a couple of things to consider from an agentless monitoring standpoint, which is monitors have a value in the properties section, or the modules do, where you can set remoting equal to true. That has to be set if you're going to do agentless monitoring. If you're using scripts, this is kind of self-explanatory. If you're using scripts, you need to not say localhost in your script or not use dot in your script, because then it's going to run on the machine that's doing the agentless monitoring, not the machine that's being monitored. And finally, you want to make sure you use APIs that support remote execution. But out of all these, cookdown is the most important. It's also the most complicated. We spend about 4 hours on it in the class, so that's kind of the high level I wanted to give you. So, in summary, this is what all we've covered, a whole lot. We've covered introduction to management packs, tools for getting the job done, and all these different tips, from basic to advanced to expert. I've got information in my slides. I've got some great links. Matthew Long's website. Matthew helped me put this together as a coworker. I want to give him a special shout out. His website, he actually did some blogging this week on the Visual Studio extensions for building 2012 management packs. So, and I'm more than happy to send you all these links. They'll also be in the slide decks as well. Special thanks to Matthew. Finally, here's my information. Feel free to reach out to me at any point in time. Also, please fill out your evals. They go from 5 to 1. And fill them out. Leave comments. I'd love to know what you thought of the session. I've got 1 minute and 55 seconds. I will be glad to answer questions, but I'm kind of deaf, so you'll have to talk really loud. Otherwise, as soon as I shut down, I'll answer questions right over here. And if you don't want to stay for questions, thank you very much for coming. All right, you had a question. You got to talk loud, though. Okay. Do you always use what? For building 2000, if you want to build 2012 specific management packs, you would have to use the Visual Studio and Visual Studio extensions. As from a standpoint of how that's changed in the product itself, it's no longer quite as graphical. You don't have all the wizards. You have some other tools in there, some other tabs, some other features, but you're doing a lot more XML programming by hand. in the 2012.
Okay, so it's not that easy.
So it's but in some ways it's a little bit easier, and that's why I recommend you go to Matthew's blog, because he's got some examples of how to do discoveries and other things using the 2012 extensions for Visual Studio. Matthew Long, which